Okay, very briefly before we do endochondral, I just want to wrap up this intramembranous just with this final steps because I just rewatched the video and the last minute was kind of iffy just how I was describing things. So first we want to just define, in the end we're going to have this outer layer called the periosteum. These osteoblasts have differentiated into this thing called the periosteum. Deep to the periosteum, we're going to get this layer of compact bone because those osteoclasts have remodeled our spongy bone into compact bone all around the edges. And then we're going to have this layer of spongy bone in the middle. So the spongy bone in the middle is going to have these different plates and a cavity and plates and a cavity, plate, cavity, like that. And we can fill those cavities with this red bone marrow. So in the end, you have periosteum, compact bone, spongy bone, from superficial to deep. Now we can do endochondral ossification. So here's my template from before. Same thing, same stepwise process, but again, we're just getting a few different names here. So our starting material for this one, and remember we're moving on to endochondral ossification. So endo meaning within, chondral referring to cartilage, so endochondral ossification. So again, we love to break up these root words. So endo can mean within, it can be that lining layer, but right now we're talking about within. Chondra, this refers to cartilage, so we have things like, we've seen tissues, these layers called the perichondrium before, this layer surrounding cartilage. We've seen chondrocytes, these cartilage producing cells. And so this is going to give us an indication into what our starting material is, and our starting material for endochondral ossification is hyaline cartilage. So I'm going to write all this stuff out first, and then I'll draw the picture, and then once again we'll connect it. So our starting material is this hyaline cartilage template. Now we're going to get a signal. For intramembranous ossification, we weren't exactly sure what that signal was, but we do have a specific signal, and it's arrival of the blood vessel to this perichondrium, to this layer surrounding this cartilaginous template. So arrival of a blood vessel to the perichondrium. This layer surrounding this cartilage. What is going to happen? And so this is considered, we talked about long bone anatomy. So this arrival of the blood vessel to the perichondrium, this is happening in the center, in the middle of the diaphysis, so the diaphysial portion of this long bone. So this blood's going to come and it's going to cause osteoblast activity. So before we talked about the center of ossification with this accumulation of osteoblasts, these are going to form a little bit differently, or they're going to accumulate a little bit differently. So now our osteoblasts, these are going to form in a ring around the diaphysis called a bone collar. And again, I'll draw all these pretty soon. So what's going to happen? Osteoblasts are going to do two things. They're going to divide and secrete matrix, just like they normally do. So we'll say divide and secrete matrix. Now they're dividing inwardly. Before we saw the fibrous connective tissue, they're just kind of dividing outward and secreting matrix as they move towards this border. Now they're on the outside in this bone collar of this hyaline cartilage template, and now they're dividing and secreting inwardly. So as we're dividing, these blood vessels are following it. Remember, we have this arrival of blood vessels to this perichondrium. So as these osteoblasts are dividing, forming this bone collar secreting matrix. We're having blood vessels follow this, and these blood vessels are bringing things like calcium and phosphate that can be deposited into the matrix to help it harden. So this is how we're going to start getting spongy bone formation. So our matrix is hardening, we're getting this stuff, this hydroxyapatite, this calcium phosphate salt deposited. These blood vessels are following. We'll give a name to these blood vessels. So these blood vessels that are following and infiltrating, we're going to call this the periosteal bud. So the periosteal bud is this network of blood vessels that's invading these spaces as spongy bone is formed. And now that we have these blood vessels, we know these blood vessels are going to be converted into red bone marrow. But before we had osteoblasts being isolated and then they die because they're isolated from blood supply, and that's how we got the spaces. So for this hyaline cartilage template, it works a little bit differently. So instead we have these things called chondrocytes within this hyaline cartilage. These chondrocytes are cartilage producing cells. And what's going to happen is as these blood vessels are penetrating, we're going to get this change in pH. So this change of pH, this is causing our soluble ions, this calcium phosphate, to go into this insoluble salt, this calcium phosphate salt, and this change in pH is also causing these chondrocytes to die and burst. So every cell, every tissue, every organ has a homeostatic range for pH, and whenever we bring these blood vessels, this change in pH causes these chondrocytes to die and burst. So let me change color slightly so we can see this. We know with spongy bone we need our trabecular plates. So whenever we have this secretion of matrix and these blood vessels changing pH, this is where we're getting our trabecular plates. How do we get our red bone marrow this time? So once again, to compare from before what we've already learned, before we had isolation of osteoblasts dying because of isolation from blood vessels, and that's going to give us this space. This time, as this matrix is being secreted, as this hydroxyapatite is being laid down, these blood vessels, this periosteal bud is infiltrating, changing this pH, and these chondrocytes are dying and bursting. So now, once again, we have this space for these blood vessels to infiltrate and differentiate into red bone marrow. Okay, I want to get a picture up before we talk about the osteoclast activity, just so we can get a visual representation of what's going on. What have we talked about so far for endochondral ossification? So if I start with my hyaline cartilage template, here's that. We know with our long bone we have the central portion called a diaphysis, and these portions a proximal and a distal epiphysis. Epiphysis. Okay, so this is hyaline cartilage. This is our starting material. Our next step was a signal, and our signal is this arrival of this blood vessels, this blood connection to the center of the diaphysis. So here's the diaphysis, here's the center of the diaphysis, here's a blood vessel. That blood vessel is going to cause some changes, which will get these osteoblasts to accumulate in a ring called a bone collar. So this is the ring on the outside, and it would go all the way around. So if I took this bone, and I was looking at, like I cut it into a central part, so just cut that in half just to look at the diaphysis, I would see this bone collar forming like this. So this ring of osteoblasts. Osteoblasts are going to do two things. They're going to divide and secrete matrix, and I actually want to make this a little bit cleaner, just so that we can see the division a little better. So here's our ring. There's our bone collar. And then let's show that blood vessel. Here's the blood vessel. And now I'm going to have this division inward of these osteoblasts, as well as secretion of matrix. So secretion of matrix, and now If I do a chondrocyte, we have this hyaline cartilage as blue. So remember, chondrocytes are stored in these lacunae. So here's a chondrocyte in the lacunae. Here's a chondrocyte in the lacunae. As my blood vessels are infiltrating, following this matrix and these osteoblasts, they're going to cause this change in pH, which will cause my chondrocytes to die and burst. So there's my bursting of there. And then I can get the infiltration of this periosteal bud, these blood vessels, to make my red bone marrow. So far, what steps have we done? We have starting material with this hyaline cartilage. We had a signal, which was this arrival of the blood vessel to this perichondrium. So we're still perichondrium right now because we're cartilage. And that's going to cause accumulation of these osteoblasts in this ring called a bone collar, where they're going to divide inward and secrete matrix. As this periosteal bud, or this network of blood vessels, infiltrates and continues to follow, it's going to cause the bursting of these chondrocytes. And once you have these empty spaces, we can have this we can have red bone marrow formation. So now we're up to the point where we have spongy bone, because we have trabecular plates and we have red bone marrow. Alright, so this next thing that's happening, this same process, division of osteoblasts, secretion of matrix, chondrocytes bursting and dying, infiltration of periosteal bud to make red bone marrow, that's going to happen in both directions. So we're going to start moving from the diaphysis up towards the epiphyses with this same exact thing happening. So as these osteoblasts are dividing from the middle towards the ends, we're going to have osteoclast. So that's this last step right here, right? We've seen spongy bone being formed and the steps to get red bone marrow. Now with osteoclast activity, we said osteoclasts do two things. They take spongy bone and they turn it into compact bone, and they also form and maintain medullary cavities. So let's see it do that. I guess first what we'll do is we'll take the osteoclast on the outside, and we'll get this conversion from this spongy bone into this compact bone. So I'll draw maybe some of these osteon units, these concentric circles, these rings of lamella. So osteoclasts are going to cause that to happen. We'll still have some spongy bone in between there, or in deep to our compact bone, we'll still have some spongy bone. So let's draw that. That was that hardened matrix. And there's a cavity for red bone marrow, and that's a cavity for red bone marrow. That's a cavity for red bone marrow. You get the picture. And then the last thing is this formation of a medullary cavity. So that's this all the way down here. So whenever we saw the Haversian canal, that central canal there, that was in one of these osteons. That's like, I'm trying to draw a circle. That right there, that'd be the Haversian canal that blood vessels and nerves run through. We're looking at something different. We're looking at this, of the whole long bone, we have this canal, this medullary cavity. This medullary cavity is made of yellow bone marrow, which is filled with adipose tissue. So a type of connective tissue. So, in recap, once we have this spongy bone from this whole bone collar dividing inwards and whatnot, we have spongy bone. Then we're going to start making spongy bone from the diaphysis towards the epiphyses. As spongy bone is being formed, osteoclasts are coming in behind and reforming the spongy bone into compact along this outside closest to the perichondrium, and then in the center it's creating this medullary cavity. Okay, so that's happening, as well as the arrival of blood vessels to the epiphyses. So this first thing, before we had a center of ossification for our intramembranous, now we're going to get primary center of ossification in that center where at the diaphysis. And then this second part where these blood vessels are coming to these epiphyses, these are called secondary centers of ossification. And the process occurs similarly but a little bit differently. So instead of this bone collar, we're just getting division of osteoblasts. My osteoblasts are green, so I'm keeping them green. Division of osteoblasts, secretion of matrix, infiltration of blood vessels to make bone marrow, red bone marrow. And then osteoblasts are going to come back and turn this spongy bone into compact bone around the edges. So you have spongy bone deep to this superficial compact bone. Anything else that we want to mention with this? Secondary center of ossification. Remember, no medullary cavity in the epiphyses. The medullary cavity, the osteoclast activity making these medullary cavities is only happening in the diaphyses. The osteoclasts are responsible for spongy to compact bone in the epiphyses, though. Okay, so the last thing is, remember, we had hyaline cartilage. All this blue stuff was hyaline cartilage. So at the very end, we're going to have this layer of hyaline cartilage remaining because this is that articulating surface of the bone that we talked about. And this is where two bones are going to meet, and so you want this layer of cartilage to help protect against friction and whatnot. So layers of hyaline cartilage. And then, if you remember, all of this was, everything I'm highlighting was all hyaline cartilage. So we said that this bone was being formed in two ways, going up and down from epiphyses, or from the diaphyses towards the epiphyses, as well as from the epiphyses moving inward towards the diaphyses. But all of this was cartilage, so we have remaining layers of cartilage, and let me clean that up. We have a layer of cartilage here, and a layer of cartilage here. This is called the epiphyseal plates. So epiphyseal plate. So this is remaining cartilage, and this is where bone growth in length is going to occur. Let's go through this picture one more time with these words. Starting material, this hyaline cartilage template, this blue template that we talked about. We have a signal. Nothing in the body happens without a signal. We get this arrival of the blood vessels to the perichondrium in the diaphyseal portion of this long bone. This is this primary center of ossification. That signal, this arrival of blood vessels, is going to cause the accumulation of these osteoblasts in this ring called a bone collar. They're going to divide inwards and secrete matrix. They're going to do what they do, which leads to the production of spongy bone. So we're getting this matrix produced, getting this spongy bone laid down, because as the matrix is being laid down, blood vessels are following, bringing in these calcium and phosphate ions to make this hydroxyapatite. So we're getting this hardening for our trabecular plates, and then as the blood is moving in, the changing pH is causing these chondrocytes to burst and die. So you have these spaces, these hollow spaces for the periosteal blood to infiltrate to then become red bone marrow. So we've got all that going on. We're getting spongy bone made throughout this whole portion of the diaphysis, and then we start dividing upward and downwards towards the proximal and distal epiphyses. And we're getting spongy bone made in that same process. So osteoblasts are dividing, chondrocytes are bursting, blood vessels are infiltrating, all that. Okay, as that's happening, we're getting this remodeling by osteoclasts from spongy bone to compact bone along the edges where the perichondrium is. So we're turning that spongy into compact, and then in the center we're making this medullary cavity. As this is going on, we're getting to the division towards the epiphyses. We're getting this arrival of blood vessels at either of the epiphyses, and those are called the secondary centers of ossification. Arrival of blood vessels causes accumulation of osteoblast activity, secretion of matrix, and division of cells, and deposition of hydroxyapatite, infiltration of blood vessels to make red bone marrow, and then we get osteoclast remodeling spongy to compact. But the epiphyses do not have a medullary cavity. What's remaining of cartilage, we have these two ends, the hyaline cartilage are at the articulating ends of bones, and then in this transitional layer between the epiphyses and the diaphyses, we have these epiphyseal plates. Alright, cool. That is endochondral ossification. What bones are formed in each? Endochondral is going to lead, well, instead, actually, let's do intramembranous. Intramembranous, this is your skull bones and your clavicles. Almost all the other bones are going to use endochondral ossification process. Cool, so that is endochondral ossification, and we'll move on next to growth in length and width of bone.